Hey everybody. So I know everybody was a little bit confused about um, the fluid calculations because we went through them so quickly. So I thought I would put together a little video so that you could kind of see me walk through how I figured all that stuff out. So when you're determining initial resuscitation for a burn patient, you need to determine the fluid resuscitation rate as well as the basal fluid requirement rate in order to figure out how much fluid they should receive in 24 hours. And so the way that we're going to do that is we're going to figure out the fluid resuscitation rate using the Parkland formula. And the Parkland formula is 4 mils times weight in kilograms times the burn percentage or the total body surface area that was burned. And we have some history up here that I just copied from the case study. So we can go ahead and figure that out. So that would be 4 mils times the weight in kilograms, which is 81.8 kilos, times the burn percentage, which is 41.5%. And that's going to give you a rate for the Parkland formula. So let's see, my calculator, 41.5 times 81.8 times 4 should be 13,578.8. So 13,578.8 mils. And then we need to figure out the basal fluid requirement. So the basal fluid requirement is 1,500 mils times the body surface area. So we determine that with the molecular formula. And this is that formula that was, that bright yellow equation in the PowerPoint in the pre-brief. So I'm going to take, let's see here, the height. So the height in centimeters is 182.9 centimeters times the weight, which is 81.8 kilos. And then you're going to divide that by 3,600, and then you take the square root of that. So if you do that, you'll get 2.04, which will be your body surface area. It's actually meters squared is the unit. So then we're going to plug that number back up into this equation. So you'll get 1,500 mils times 2.04, which will give you 3,016 mils. So then we're going to take this number. I guess I can use my fancy pointer here. We're going to take this number and we're going to take this number and add them together. And that's going to be your 24-hour fluid requirement. So you're going to say 13,578.8 plus 3,060, which will give you 16,638, 639, I guess, because it's 0.8. So that'll be your total fluid requirement for 24 hours. And then we need to split that. So we're going to do half of that amount in the first 8 hours. So you're going to divide that by 2. So we'll take 16,639 divided by 2, is going to give you 8319.4. So that first half is going to be given over 8 hours. So you're going to take that number or divided by 8. That's going to give you about 1,000 an hour. So 3040 mils per hour. And then the next 16 hours, you're going to get the last half of that fluid. So you're going to take 8319.4 divide by 16, and you're going to get, should be half that rate. 83. So you're going to be giving 519.96, which is 520. So you're going to give this. So in the first 8 hours, you're going to give 1,040 mils per hour. And in the second 8 hours, they do it like this on the protocol. You give 520, I think it's to avoid confusion. And then the third 8 hours, you'll give 520 as well. Now this is a guideline, like we looked at the other, we looked at the algorithm. It changes based on your urine output. So if you have urine output issues, you're going to start the algorithm at this 1,040 per hour. So let's do the rest of it based on that 1,040. So we are going to start with 1,000. So if your urine output is 1 hour and 100 is 20 mils, your second hour is 10 mils, your third hour is 5 mils. We're going to base it off of this 1,040. So we have our current rate is 1,040 mils per hour. So let's say this is up here because this is what it was at previous. So when you have when you get 20 mils per hour of urine according to the protocol, that means you're going to change it by 10%. You're going to add an additional 10% or 100 mils, whichever is more. So that would be 1,040 times. So that's going to give you a rate of 1,144. So then the next hour, you're going to also add fluid because your urine output is still low, but this time we're going to add 20% based on that fluid volume or that urine output, or 200 mils, whichever is greater. So that means we're going to take the 1,144, figure out how much 20% is, and then add that to the total. So you'll end up with 1,319 72, 73 mils per hour. And then in the next hour, we're also going to add 20% because of the urine output, or 200 mils. So we're going to take that 1373 times 0.2, and so you'll end up with 164748. So that'll be the number that you'll be giving after 3 hours of having poor urine output of that urine. Um, and it could go the other way if the urine output was too much, according to the protocol as well. And then based on that urine output, it's been 2 hours of less than 15 an hour. I think it's 15 an hour that it calls for. You will also consider the 1/3, 1/3, 2/3 albumin protocol. So the way that we get that is, let's see, let's go over here. You would take your 1648 mils. You're going to multiply that by 0.33, or 1/3. And that'll be 543.84. So you'd round that to 544 mils per hour of albumin, which is 5% albumin. And then you will subtract 1648 minus 544, and that's going to give you 1,104 mils per hour of LR. So hopefully that kind of clears some things up. If you guys have more questions, please let me know. And I'm sorry that it went so fast over the case study. Hopefully this will make it a little bit easier for you guys to figure out. And yeah, definitely reach out if you have any more questions.